Under the Paris Agreement, EU countries are committed to making the EU climate neutral by 2050. To achieve this goal, the transport sector must undergo a tremendous transformation towards sustainable mobility to achieve a 90% reduction in greenhouse gas emissions by 2050, compared to 1990 levels. Electric cars are essential to meeting this ambitious challenge, and innovative charging solutions are needed to answer expectations for growth and acceleration of the transition. INCIT-EV examines innovative charging technologies aiming to improve the EV driver experience and increase electric vehicle usage past early adoption and into mass market acceptance in the EU. The INCIT-EV User Case 1 explores user-centric smart charging and bidirectional charging innovations at 3 different aggregation levels.
As a charge point operator, we are facing grid congestion on a daily basis. That requires us to come up with different solutions like energy storage or combining grid connections. But we can also make use of the flexibility in our network to reduce actual grid congestion. The use case in Haarlem aims to test this principle while maintaining a reliable charging service towards our customers.
As a distribution system operator, Leander, our aim is to mobilize flexibility so that we can make sure the grid is used as good as possible. To mobilize the flexibility, we use a multi-layered approach, making use of both information campaigns, time-of-use tariffs, also policy instruments and market-based propositions. In this pilot, we were able to test how Total Energies could use their group of charging stations within the intraday market. We used GoPacks to see how to facilitate this, which is kind of a new thing in the Netherlands.
By pooling a group of chargers in the city of Haarlem, we were able to participate in flexibility markets. To optimize the EV drivers' charging experience, we partnered up with Greenflux.
In this partnership, Greenflux is responsible for translating the power set point from Total Energies into individual charging profiles to ensure that this power set point is followed. By taking multiple inputs into account, such as charging behavior of the electric vehicle, starting time of a charge session, or EV driver preferences, this is done in a smart way so that the impact on the EV driver is minimized.
Together with the municipality of Haarlem, we contributed on this smart charging project. There's actually real charging stations being used for this project. Results of the research show that the charging sessions are still reliable and that the customer satisfaction remains high. And that's really important for the metropolitan region of Amsterdam and of course also for the municipality of Haarlem to make sure that the electric drivers are happy with what's happening on their charging stations. We're also really happy that we use the charging stations to see if we can help the electricity grid, which is highly under pressure. We believe it's important to use the charging stations to create more flexibility on the electricity grid. And the results show that it's also possible to do this while maintaining the reliability of the charging stations. The lessons from this project will be used in all other cases.
Here in Oudijk, WeDrive Solar has demonstrated smart charging of electric vehicles at community level, which has been a very important experience for new housing locations in the Netherlands. In this new area, het Burgje, new households were offered a subscription to the WeDrive Solar car sharing system, which reduced the private ownership of cars. Important aspect of electrical vehicles is minimizing the load on the power grids. Here in the Burgje we have successfully demonstrated smart charging with a coupling to the reservation system of the electric vehicles. A challenge in the development of this market is interoperability between all the brands of cars, chargers and ICT backbones. Car sharing fleets, because they have central systems and larger volumes, are a very good way to initialize this interoperability.
Okay, we are here at Triodos Bank head office in Utrecht region. And it's a special day because today we are installing a new set of 5 bidirectional charging stations for AC bidirectional charging. And these chargers, they support the latest standard for ISO 15118-20. So this has been quite a long road to get here, as it took longer for the market to finalize this standard 2 years ago, finally. and for us to be able to develop and test these chargers to be sure that what we put in the field actually is capable to do bidirectional charging for real.
For the project, we selected the use case of an apartment block in Purmerend near Amsterdam with 21 apartments and an owners association. And we helped them in the decision-making process. And we translated these lessons from the use case to the national level. There are three main challenges in the decision-making process for the owners association. One, the technology, the selection of the right charging infrastructure, the grid connection and the extension of the grid connection, and then maybe a third part in this particular case, the integration of already installed charging infrastructure into the whole system. Second challenge has to do with the actual cost of the charging infrastructure and the financial agreement within the owners association. It's not only who pays the charger, but also the infrastructure for the chargers, the grid extension, all these kind of things have cost, and how to distribute these costs among the different users, that's a large part of what they need to agree on. The third challenge is the decision-making process itself, and it's hard for the owners association to organize this because it's only organized once a year, these kind of meetings. And they have to have the right basis of support in order to support the technology chosen and also things like the safety measures they taken. And if they don't, they have to wait for another year. The results of the projects are twofold. One, the owners association has selected a charging infrastructure and created charging infrastructure for the entire apartment block, 12 chargers to start with. And second, the lessons we took from this project, we taken to the national level and organized webinars for more than 200 participants regarding this topic.
This user case demonstrates smart charging at 3 aggregation levels, each presenting unique challenges. The Haarlem demonstration showed that smart charging at public stations can alleviate grid congestion whilst maintaining excellent service for EV drivers. Similar positive outcomes were observed in Oudijk, where smart charging for shared EVs integrated with a reservation system successfully reduced load. This demonstration was expanded to a second location featuring AC bidirectional charging with the latest ISO 15118-20 standard. Additionally, the apartment building in Burgmond highlighted the complexities of installing charging infrastructure for homeowners associations, particularly in the decision-making process. The insights gained here have been used to develop a step-by-step plan for future installations. These demonstrations have significantly advanced our understanding of implementing smart charging in real-life scenarios, paving the way for broader adoption and mass market acceptance of electric vehicles in the EU.